Hello friends, this is Akulmach live and I am Chandrakant. And for past few days, I have been putting daily challenges. These are logical in nature, and I want the viewers of our program to solve those logical puzzles. And fortunately, I am very honored and pleased to have one of the person who actually cracked it in less than 5 seconds, and he was one of the first few people to crack challenge 5. So we will invite him in our show and solve the puzzle together. Before we start this exercise, I must tell you, folks, that please stick around to this outstanding show as there is a giveaway, and we will tell you in the end how you can win your free gift. Welcome back, friends. And today in our show, we are actually solving one of the challenges. As you know that we are putting some challenges for people to participate. And these are all very simple challenges which involve geometry, mathematics. And today, I'm honored to have Mr. Neville Gaunt on this show because he is one of the first person who solved this challenge. These are very easy challenge, but we will have Neville to talk about that. Welcome to the show, Neville.
Good morning, CK. Good morning, everybody. Well, I don't know about one of the quickest, but it's basic geometry, isn't it?
It is basic geometry, but I called it a challenge because I wanted to bring in more elements so that people get confused, but they have to think straight and logically.
And you're absolutely right. We need to think straight and logically. And like anything else, we can all look at something and we can go, oh, that's a bit complicated. As indeed, I expect the majority of people did when they saw your little puzzle. But the simple things in life are simple. And to get the answer to the puzzle, we need to break it down into component parts. Now, I can tell you what the answer is. It's in the back of the book, but don't look, it's cheating. The reason is, so why do we need to know this stuff? So this is the issue that a lot of young people, particularly when they're learning maths, because geometry is maths, okay? They say, oh, it's boring. Oh, why do I have to learn this? You know, it's going to have no impact on me whatsoever. But the answer is there's actually a reason for everything. And basic geometry has got some really good foundations in your practical life. So, for instance, CK, okay? What would be a very practical solution that you're looking for if you need to use geometry in your house? You know, because when you get older, we're all homeowners and we all like doing a little bit of DIY. Or if we like buying furniture and we like to see, you know, roughly what things look like. And I know you can go online and you can get apps for all this stuff, but it's a lot easier if you take a tape measure and a piece of paper. So one of the most practical things that I learned from geometry was when I first was told about a rectangle. So when you just draw a rectangle, there you go, there's a rectangle. You imagine a rectangle in your head. It's got equal sides that way, equal sides that way. That's the benefit of a rectangle. And the area of a rectangle is this length times this length. And we learn that from basics. So why is that useful? Why do you think that's useful?
Well, because in my opinion, everything is rectangle and we have very few squares. So we need to know, what is the area of my room so that I can fit in this couch or fit in this sofa or get the flooring done. So I think these are the basic requirement. These are life skills which we must have.
Yeah, absolutely. And you mentioned a square, and that's a very special rectangle because it's equal sides all the way around. And there are fascinating things that we learn about rectangles. So if we know that the area of a rectangle is one length times another, what's half the area of a rectangle? Well, it's simple. It's half one length times the other. But now draw a rectangle in your mind and split it in half. How many ways can you split a rectangle in half, CK?
Well, I think about 3 ways. You can cut them horizontally, vertically, or diagonally.
Yeah, I mean, our teachers used to say, put a mirror because you want half and half. So if you put a mirror down the middle, you definitely get half and half. If you put a mirror horizontally across the middle, you definitely get half and half. And if you put a mirror diagonally, I'm not too sure you get half and half, because actually it doesn't quite look like a rectangle when you look in the mirror. It looks like a kite. Then all of a sudden you start to think about different areas, different spaces, different objects. But the nice thing is, you now know the answer to the puzzle. So let's have a look at the puzzle, shall we?
Well, Neville, the puzzle was like this. I have classified this as circles and tangents. And as you can see, just few minutes I will explain to the viewers. There are 2 tangents which are now. So hopefully people know what is a tangent. It is a line which just touches the perimeter of the circle. And in this example, what is happening is there are 2 tangents coming from both sides of the circle, and then they are at an angle and intersecting each other at certain distance. And then from the where the point the tangent touches the circle, there is a line which connects to the focal point, and that line is called radius. And I asked the viewers, can you solve this area which is surrounded by yellow lines? So that was a puzzle basically, Neville.
Excellent. And immediately when people look at the title, Circles and Tangents, they'll go, oh, no, I don't remember that. Oh, that's too difficult. And the interesting thing is, it's got not a great deal to do with the circle, apart from there's a radius, and there are 2 radiuses, and they're equal. And it's not got a lot to do with a tangent, apart from a tangent forms a right angle with a surface that it's attached by to the radius. So here's the problem. Immediately people go, oh my goodness, circles and tangents, I don't remember that. Well, ladies and gentlemen, it's got nothing to do with circles and tangents, and everything to do with a rectangle, or more importantly, a triangle. Because it's a right-angled triangle. And the beautiful thing about a right-angled triangle is, we're going to go back to our little example earlier of a right-angled triangle is just half a rectangle. So if you can now, I don't know whether you can do this. Can you see, Kate? Can you draw a line from the center of the circle to the point of the radius, of a point of the tangent?
I can do that, Neville.
Doesn't have to be perfect, just... Well, brilliant. Oh, that's not bad. Yeah, that's pretty good. That'll do. Excellent. So now what we've got is we've got 2 triangles. But the beauty thing about that is those 2 triangles are exactly the same. So all you need to do is know the area of a triangle. And I've told you the area of a triangle before. It's half the base times the height, because it's just a half of a rectangle. And it's as simple as that. So you can break these puzzles down into very, very simple geometry. But the reason is why you need to use it is most important. So on the side of any paint tin, it says, this paint tin will cover 10 square meters. Well, it's pretty good to know how many square meters in your house you want to cover to know how many tins of paint you need to use. And not all tins of paint say 10 square meters. Some might say 5. Some may say 7.5. Some will say this needs 2 coats and it will cover 15 square meters. So all of these things that CK is putting up here have got some practical use. So I hope that makes sense. And it's a very simple, this is a very simple question, but what you need to do is see through the red herrings. Get away from that which is distracting you. And look at what you're being asked to do. So each of these triangles is half the base times the height. And we've got 2 triangles, so it's double. In essence, what you've done is you've formed the original rectangle. Does that make sense? There you go. There's your answer. So what looks as complicated in first thoughts isn't complicated because you can always break it down into component parts.
Absolutely, Neville. In fact, I gave the hint, and that was a very big hint. And I have mentioned that it's a 90-degree angle, so it should be straight away clear to the people that it's half of the rectangle. And we are trying to show that in dotted lines here, that had it been a rectangle and we have divided that diagonally, then it will look like this in the blue dotted line. And so the area of a triangle, of a right angle triangle, is basically height into base, and that is half of it because it's half of a rectangle. And since there are 2 rectangles, 2 triangles, or 2 fictitious rectangles, all you have to do is basically multiply by 2, and that means this is basically a quadrilateral, which is height into base. The answer is very, very simple.
There's always a simple answer, but you have to just break down the problem. So once you've broken down the problem into its component parts, you get to the answer very quickly. But like anything else in life, you can be confused by the title, circles and tangents. The context is the triangle.
Absolutely, Neville. In fact, this is exactly why the challenge is tricky, and it's a challenge. It's a puzzle. It's not a mathematical problem. It's a challenge how logically you think. And some of these challenges that we are putting now are very simple in nature. People have to just look at it, and like you are explaining it, it's half of a rectangle times 2, and that is a solution for this challenge. There is nothing to do with tangents or 2 pi r, or none of those formulas are required in this. It's a very, very simple challenge, which you are the first one to crack in less than 5 seconds. In fact, I gave 3 minutes, but you cracked it in 5 seconds.
Well, I'm not. To me, it's never a race. It's about trying to do the right thing. But the key thing is, everybody, is break down the problem into little component parts, and then makes life a lot easier. I've got a challenge for you, CK. I would like you to imagine, in fact, you could even bring a whiteboard up if you like. I would like you to imagine drawing a clear piece of paper and drawing a small circle on that piece of paper and colouring in that circle so that you've just got a dot on the screen. Can you do that? A small circle on the screen. It's not small either, but anyway. That's better. Right, just colour it in with the same colour. With the same colour, just go backwards and forwards and okay, that'll do. Well, here's a whiteboard. Okay. Now, I want you to close your eyes. Take your hands off the screen, off the keyboard, and close your eyes. Okay? Close your eyes. I can see they're open. Close your eyes. Okay. In a minute, I'm going to ask you to open your eyes. And I'm going to ask you the question, what do you see? Are you ready? Okay, open your eyes. Now, what do you see? Explain to people what you see.
I see a very bad drawing, a round shape bad drawing in blue color.
Okay, anything else?
I think I also, it looks like a sphere to me, not a plain circle.
Okay. Looks like a sphere. Anything else?
It is the only thing on that white sheet.
Okay, now we're getting there. Okay. Because what you've done is what everybody does. They focus on the small things. They're not focusing on the white sheet of paper. What you could do with that white sheet of paper, how big that white sheet of paper is. The fact that this little blue dot that you've drawn pretty badly that looks like a sphere has no relevance whatsoever because it's on a huge white sheet of paper. Why did you draw it in the middle? Is it in the middle? Is it to the left? Is it to the right? And this is just making a very simple example of what we were doing earlier. We focus on those things and we go, oh my goodness, I've got to explain that little thing. And that's not how life works because there's much bigger things out there that we don't look at because we've been asked to focus on something else. Now, I didn't ask you to focus on the blue dot, did I? But I asked you, what did you see?
Absolutely, Neville. You didn't ask, you did not give me a puzzle to solve. You just asked me, what do you see?
And it's as simple as that. And that's why life gets complicated, because you don't see all the wonderful things around the blue dot. You just see the blue dot.
Absolutely. So viewers, there are more challenges like this. I'm hoping that you will solve this. In fact, there is one very interesting which is called circles and triangles, which is challenge 1. That is very, very interesting and slightly more difficult. And there are easy ones also. So hopefully, just like Neville has solved it by looking at the problem, you should be able to solve our challenges. These are very simple but logical in nature. All you have to do is cut the clutter and solve our challenge. Thank you, Neville, for coming and providing this solution to our viewers. And we will catch up in the next solution. Until then, I'd like to say goodbye for today.
Cheerio, everybody.
We have some unique Akulmach memorabilia which will make you look outstanding. The graphics on these corporate gifts are based on the global best business practices. To become recipient of one of these gifts for free, you have to watch this video till the end and provide your valuable comments. Or you can also share your experiences. The person who makes the best comment would be chosen to become a recipient of these beautiful Akulmach gift, absolutely free, delivered to your doorsteps. The winner would also get a chance to be invited live as a distinguished panelist during our next video. What are you waiting for, friends? Please subscribe Akulmach and smash that